right, so ready to jump into another deep dive. Today, we're cracking open a recent edition of Prateek Singh's Beyond the Code newsletter.
You know, if you're in tech, AI, cloud, software, systems, Prateek's insights are pure gold.
Yeah, he really cuts through the noise and gets to the heart of what matters.
Exactly, and he doesn't just talk about it. 5 books, experience at LinkedIn, building at Gannett AI Labs. This guy is in the trenches.
Over 250 articles and open source projects, too. Clearly, he loves making complex stuff clear. That's what we're all about here on the deep dive, right?
Absolutely. No information overload, just the good stuff, the aha moments, the tools you can actually use, the insights that give you an edge.
So what's on the menu for today's exploration? Well, we're going to unpack a surprising strategy for boosting productivity in this crazy AI world.
Sounds counterintuitive, right? Slowing down to speed up.
I know. But trust me, Prateek's take on this is fascinating. Then we'll dive into advanced prompting techniques for large language models.
Think of it like this. You know how to ask a question, but now we're going to learn how to have a real conversation with these LLMs.
Yeah, unlock their true potential. After that, we're going to break down this thing called tokenization. Super important, but often overlooked.
It's how AI reads, so to speak, and it impacts everything from accuracy to cost.
Exactly. Then, get ready for a mind-bending journey into the world of embeddings and vector math. This is where AI starts to understand meaning.
And we'll spotlight a powerful open source tool you can use right now, plus touch on some cutting-edge research that's shaping the future.
You ready to dive in?
Let's go. This slow is fast idea, it really flips the script. In tech, we're always told to move faster, do more.
Right, it's like the hustle is glorified. But Prateek's personal story here is pretty eye-opening. He used to be that guy, glued to his phone first thing in the morning.
Slack, LinkedIn, email, all those notifications, trying to get ahead of the day.
Yeah, but he realized it was just busyness without brilliance.
Yeah.
A lot of frantic activity, but not necessarily the most impactful.
I think we've all been there. So how did he break free?
He implemented this 3-part reset. No phone for the first 30 minutes of the day. Radical, I know.
Wow, just silence and headspace.
Then, 5 to 10 minutes of intentional breath work. Sounds simple, but it's about grounding yourself, coming into the present moment.
And the third part?
Planning the entire day the night before. Get all the decisions out of the way so you can wake up with clarity and focus.
I love that. It's like setting your intentions for the day while your mind is still fresh. What kind of results did he see?
Oh, man. The benefits are significant. Increased focus, way less context switching, that constant jumping between tasks, it kills productivity.
Yeah, it's exhausting.
He also reported better decision-making and even more joy throughout the day. In a world that's constantly vying for our attention, Prateek argues that being present is the ultimate productivity hack.
It makes sense. When you're fully engaged, you get more done with less stress.
Exactly. All right, so hopefully we've inspired you to try putting the phone down for a bit. Now let's talk about prompting those large language models. We all know the basics, but Prateek's emphasizing that these aren't just fancy search bars.
They're collaborators, and the way you interact with them directly impacts the results you get.
Yeah, it's like having a conversation with a super intelligent assistant. He shared 5 underrated prompting techniques that his team at Gannett Cloud uses daily.
Let's hear them. What's the first one?
Role prompting. This one's powerful. You essentially tell the LLM to take on a specific persona, like act like a world-renowned astrophysicist explaining dark matter to a high school student, or you're a seasoned cybersecurity expert auditing this network configuration.
So you're setting the stage, giving the LLM a specific lens through which to view the task.
Exactly. It provides context, influences the language style, and even the depths of the response. It's role play for clarity, as Prateek calls it.
Brilliant. What's next?
Chain of thought prompting. This one is surprisingly simple, but it works wonders. All you do is add the phrase, "Let's think step by step," to your prompt.
Wait, seriously, that's all it takes?
That's it. It encourages the model to break down the problem into smaller logical steps and then articulate its reasoning. It's like asking it to show its work.
So you can see the logic behind the response, not just the final answer. That's super helpful for complex queries.
Totally. Next up, few-shot prompting. This is where you give the model a few examples before asking your main question. It's like saying, here's the kind of output I'm looking for.
So you're guiding the LLM by showing it what good looks like? When would you use this?
It's especially useful when you need a specific format, tone, or domain-specific knowledge that might not be obvious from the prompt alone.
Got it. So you're essentially priming the model with a little bit of extra context. What's technique number 4?
Format instructions. This is all about demanding structure. Don't just ask for information. Tell the LLM how you want it presented.
Like, give me a bulleted list or output this data in JSON format.
Exactly. They're surprisingly good at following these instructions, and it can save you tons of time on post-processing.
That's huge for efficiency. Last but not least, what's the fifth technique?
Self-critique prompting. This is where you turn the AI into its own editor. After it gives you an answer, you can ask things like, how confident are you in this response and why? Or, what are the potential weaknesses and how can it be improved?
Wow, you're making the LLM analyze and refine its own work. Pretty meta, right?
It is. It encourages a level of meta-reasoning that's pretty amazing. Prateek's takeaway is that a killer prompt blends context, instructions, formatting, and examples when needed.
So we're not just throwing words at the AI, we're strategically crafting prompts to get the best possible results.
Absolutely. Now let's get into this thing called tokenization. It's fundamental to how LLMs work, but it's often misunderstood.
Yeah, we tend to think of them as processing words like humans do, but it's actually quite different.
Right. Prateek explains that LLMs work with tokens. Think of them as the building blocks of text. They can be whole words, parts of words, punctuation marks, even spaces.
It's like breaking down language into its smallest meaningful units.
Exactly. He gives a great example. Artificial intelligence is revolutionary. It's tokenized into something like artificial intelligence is revolutionary.
Notice how some words are split up, like revolutionary, so why should we care about this?
For a few reasons. First, there's the model's context window. It's the maximum number of tokens it can handle at once. Like GPT-4 is 128K.
So if you go over that limit, the model starts to forget earlier parts of the conversation.
Exactly. Understanding tokenization helps you manage how much information you're feeding the AI. Second, there's cost. Many LLM services, including OpenAI, charge based on token usage.
Ah, so a wordy prompt can actually cost you more money.
You got it. Being concise is not just about clarity, it's also about cost effectiveness. Third, tokenization affects accuracy and reliability. Well, uncommon words or jargon might get broken down into weird token sequences, and that can lead to misinterpretations and errors.
So those AI hallucination that we hear about could sometimes be due to tokenization quirks.
Possibly. Now, to help visualize this whole process, Prateek recommends a cool tool, the OpenAI Tokenizer Visualizer.
Tell me more.
You just paste your text in, and it shows you exactly how it's broken down into tokens. It's a great way to see what's happening under the hood.
That sounds super helpful for optimizing prompts. Okay, so we've explored how AI processes language. Now, how does it actually understand meaning? That's where embeddings and vector math come in.
This is the really mind-bending stuff. LLMs don't understand words in isolation. They convert them into these numerical representations called embeddings, which are like points in a multidimensional space.
So instead of seeing letters, they see numbers that capture the essence of a word.
Right. And here's the key insight. Words with similar meanings have embeddings that are close together in this vector space. Prateek uses the classic example. Dog and cat are closer than dog and car.
It's like the AI has its own internal map of meaning.
And it's not just for single words. This concept applies to sentences, paragraphs, documents, even images and audio, thanks to models like CLIP.
So it's a way of representing all sorts of information in a way that AI can understand.
Exactly. Now, how are embeddings actually used? Well, one major application is semantic search. Instead of just matching keywords, it searches based on meaning.
So you can search for recipes for chocolate cake and get results that don't even mention those words but are still relevant.
Exactly. Prateek highlights Google's semantic experiments and dense passage retrieval as prime examples of this in action.
That explains how search engines have gotten so much better at understanding our intent. What else?
Then there's ARG retrieval augmented generation. This is where an LLM, before answering a question, uses embeddings to search an external knowledge base for relevant context.
So it's not just relying on its internal knowledge, it's pulling in outside information.
Yeah, it's like the LLM is doing research before giving an answer. Prateek points to the R-Wage paper from Facebook AI as a key development in this area.
Makes sense. What other applications are there?
Recommendation systems. You know how YouTube or Netflix suggest things you might like? They embed both users and items into the same vector space.
So if your user vector is close to a movie vector, that movie gets recommended to you.
Right. Proximity in the embedding space indicates potential interest. Prateek specifically mentions YouTube's research into this area.
Cool. What else?
Embeddings are also crucial for clustering and classification, grouping similar documents, identifying the intent behind text, segmenting users based on behavior.
If you have a bunch of vectors pointing in the same direction, you can assume they represent similar things.
Precisely. And then there's multimodal search. This is where things get really interesting. Models like CLIP learn a shared embedding space for both text and images.
Wait, so you can search with images or get images as results?
Exactly. You can search for a photo of a sunset over a mountain range, or upload a picture and find related text descriptions. Pretty amazing, right?
That's next level stuff. It's like AI is bridging the gap between different types of data.
Totally. And the way this similarity is calculated is through vector math, specifically cosine similarity. It's not just about distance, but the angle between vectors.
So it's not hard-coded rules, but rather patterns learned from massive amounts of data.
Exactly. Okay, let's shift gears to a practical tool. Hugging Face's repo to text. This one's for anyone working with code and LLMs.
What's it do?
It crawls GitHub repositories, grabs the code and markdown files, and converts them into clean text that's optimized for LLMs.
So it's like pre-processing code for AI consumption.
Exactly. Prateek highlights its use cases: building documentation chatbots, creating RGLI systems that can retrieve code snippets, and populating vector stores for code.
Sounds like a must-have for developers working with AI.
Absolutely. And finally, Prateek recommends 5 research papers that are shaping the future of AI.
Ooh, hit us with the knowledge.
First, the foundational RAG paper from Facebook AI. Then, the OpenAI paper on CLIV, which revolutionized multimodal AI.
Those are big ones. What else?
The SentenceBERT paper, which introduced a powerful way to generate sentence embeddings.
Okay, got it. 2 more.
The dense passage retrieval paper, which advanced semantic search techniques.
Right, makes sense. And the last one?
Research on YouTube's recommendation systems, which dives into how large-scale embedding-based approaches work in the real world.
That's an incredible lineup of papers, a must-read for anyone who wants to understand the foundations of this technology.
Absolutely. So we've covered a lot today, from a counterintuitive productivity hack to the inner workings of AI understanding.
What was your biggest takeaway?
For me, it's how interconnected everything is. The mindset shift allows for better prompting, which leverages the power of tokenization and embeddings.
It's all part of the same puzzle.
Exactly. And for you, our listener, I hope this sparked your curiosity to explore these areas further.
Absolutely. We all benefit from greater clarity and understanding in this ever-evolving tech landscape.
If you found this deep dive valuable, please subscribe for more and share it with someone who might benefit.
As Prateek says, clarity compounds when shared. And be sure to follow Prateek Singh for more insights.
So as you go about your week, consider this. How can you combine a more mindful approach to work with the power of AI tools to unlock new levels of creativity and productivity? What small experiment can you try to explore that intersection? That's your challenge. Until next time, keep exploring.